Hello and welcome to A Theory of Everything. I'm Luis Razzo. Today, in the wake of my discussion with Lawrence Krauss, we're going to revisit a question we've talked about many times and one that we'll return to often. Does the future have an impact on the present? That seems like an absurd thing to ask because we've always been taught that causation comes only from the past. The future isn't here yet, so it can't possibly affect the present. Our everyday experience and 500 years of science proves this to be the case, right? Wrong. The fact is that we haven't arrived to a complete understanding of causation, and there's growing evidence that the future does, in fact, have a causal impact on the present. The strongest and most relevant line of research in this regard is that of Yakir Aharonov, winner of the Wolf Prize and the Presidential Medal of Science. More recently, the Nobel laureate Frank Wilczek has written a paper on time crystals, which have been experimentally observed. These are potentially relevant because they suggest something that he refers to as a time-symmetric Big Bang cosmology. Here are a couple of quick video clips from each of these men to get the point across.
The main idea here is that the present is affected not only by the past, but also by things that come back from the future.
So this line of thought can lead us through interesting adventures. We can think about a time-symmetric form of Big Bang cosmology, when you have a Big Bang in the past for one kind of matter, a Big Bang in the future for another kind of matter, say that interacts with it very, very weakly, but the arrows would be different.
In addition to Aharonov and Wilczek, there are many other teams of physicists who are working on related ideas. In string theory, for example, there is a growing consensus that space-time itself is not fundamental. If this is the case, it suggests that whatever space-time emerges from, that more fundamental foundation is just as causal of the future as it is of the past. I will put links to some of the relevant research and to our own work in this area in the video description. You might ask why any of this matters. In a sentence, it matters because it potentially brings theoretical physics out of the mathematical clouds and steers it back down to earth, where things are real and testable, and where ideas are consequential. If in fact the future has a causal impact on the present, then we can ask and test to see if there's some sort of equivalence between the time symmetry of physics and our own goal-setting behavior as humans. Aharonov refers to this as the setting of future boundary conditions. If I decide to turn to the left at a fork in the road, the physical world that comes into being as a result of my decision is very different than the world that would come into being if I had decided to turn to the right. This is true whether or not I have free will, and furthermore, the same idea applies to group decisions and to decisions of the human species as a whole. If tomorrow morning every person alive decides to throw a plastic bag into a lake or river, the physical result would be very different than a world where every person decided to remove a plastic bag from a lake or a river. This connection between physics and collective decisions is promising because if we can establish the precise mathematical connection, as I contend we can, it moves politics away from the realm of personal opinion into the less controversial domain of physics. This argument may seem far-fetched, but hang in there, because the puzzle will eventually come together nicely. Remember that the primary goal of this channel is not to share my personal opinions. The last thing the world needs is another opinion. Rather, what we need is a more effective way to resolve our differences of opinion. And that's precisely what I'm arguing we can accomplish through a deeper understanding of nature. If you haven't seen the original video where we lay out a more complete argument for how to understand physics, I encourage you to do that. You'll find a link to the lecture on the screen now and in the video description. Until next time, I hope you'll take a moment to glance at the research, and thanks for listening. If you like what you heard, stick around and let's reason together.